So we've been talking about rational numbers and how they're similar to rational functions. So one of the similar characteristics that rational functions have with rational numbers is this idea of proper and improper fractions. So if you don't remember what proper and improper fractions are, here's a quick refresher. Proper fractions are fractions where the bottom is bigger. So something like 2/3, okay, 3 is bigger than 2. So that is a proper fraction. Okay, some other examples, 6 divided by 10, okay, or 1/4. Those are all proper fractions because the top is smaller than the bottom is the bigger number. Okay, improper fractions are fractions where the top is bigger than the bottom. So for example, 7/2. Okay, 7 is bigger than 2, so that's an improper fraction. Another example would be 5/4. Okay, 5 is bigger than 4, so that's an improper fraction. And let's do one more. 15/3 is an improper fraction because 15 is bigger than 3. Now, rational functions have a similar idea, but instead of looking at whether a number is bigger, we look at the degree. So if the degree of the numerator is bigger than the degree of the denominator, so this right here would be sort of the equivalent of an improper fraction, but it's an improper rational function because the degree of the numerator is bigger than the degree of the denominator. Now, the reason why this is important is because it leads us to this idea of mixed numbers. So for those who don't remember, mixed numbers are numbers like 1 and 1/4, okay, which is the same thing as 5/4. So you got improper fractions and mixed numbers, which are really talking about the same number. This is basically the number 1.25. Okay, you can think of it as having 5/4, that's $1.25, or you can have $1 and 1/4, that's still $1.25. Okay, so mixed numbers and improper fractions, we can sort of go between the two back and forth. Okay, let's maybe look at some other examples real quick. So 3/2. Okay, 3/2. Well, that's 1.5. Okay, what we're doing here is we're saying if you have 3/2, you basically have a whole plus another half. So really this is a whole plus another half, or 1.5. Okay, hopefully you're seeing that. The process for doing this, and this is why a lot of people sort of checked out of fractions when they learned this back in elementary school, the process is division. Okay, so let's go back to our example of 5/4. Okay, the way we figure out that that is 1.25, we take the 5 and divide it by the 4. Fraction is really just a division problem anyway. And so 4 goes into 5 one time. 1 times 4 is 4. Subtract to see what the remainder is. The remainder is 1. There's nothing left to drop down. I mean, you could put a decimal and keep going. That's how you get the 1.25. But if I want to write it as a mixed number, I just stop there. And I say, okay, there's a remainder of 1. So this is telling me that 5 divided by 4, or 5/4, is equal to 1, because 4 went into 5 one time, and then plus 1/4 because there was a remainder of 1, and our original quotient is 4, so it's 1 out of 4 left over. Okay, so 1 and 1/4 is the mixed number version of 5/4. Long division helps us get there, and there you go. So mathematically, what we want to say here is that if you have a fraction a over b, okay, like we did 5/4, you can sometimes rewrite that as some number that's the quotient of the two when you divide them, plus a remainder out of b. Okay, in this case, our q was 1, the red one here, and our r was the remainder, and then our b is the denominator of the fraction, in this case 4. So 5/4 equals 1 plus 1/4. So rational functions have something similar. If you have the rational function a of x over b of x with your polynomial on the top and the bottom, Okay, we can divide those polynomials just like we did in the first chapter this year, and that's going to give us some answer plus some remainder out of the denominator. So you can watch the next video. They give you an example of that. If you remember how to do long division with polynomials, you're basically all set to turn these rational functions into mixed functions, we'll call them for lack of a better word.